All right, so we saw Hamilton's method, and now we're going to look at a few different methods. And what we're trying to do is we're trying to avoid the Alabama paradox, the new states paradox, and the population paradox that came up with Hamilton's method. Now we're going to look at three different methods: Jefferson's, Adams, and Webster's methods. And they all have a very similar theme. So once we've seen Jefferson's, Adams, and Webster's method will go very quickly. All right, so in Jefferson's and Adams and Webster's method, they all come down to choosing the right divisor. All right, so here's what Jefferson's method is going to do. Obviously, this was named after Thomas Jefferson, one of the founding fathers of the United States. So first off, instead of using the standard divisor, right, which we had earlier, we had the standard divisor, we're going to nix that. We're going to cut that out, and we're going to replace it with some new modified divisor, is what I'll call it right now. All right. And once we have this modified divisor, we divide all the populations and get this modified quota. Okay, so instead of using a standard divisor, we'll do the same thing with a modified divisor. And then if we've picked the right divisor, then we simply give everyone the lower quota, and it all works out perfectly that the lower quotas on everybody add up to the right number of representatives. So let's take an example, all right? And we saw this example in the first idea last section. We had 100 representatives, and A, B, C, D, and E had those populations that we see here, right? 38,000 and 21,000 and so on and so forth. If you remember, if we did Hamilton's, the standard divisor was 1,000 because the amount of this population was 100,000 people. We wanted 100 representatives, so that comes down to a standard divisor of 1,000. So what we're going to do is in Jefferson's method, we get rid of the standard divisor that we used in Hamilton's. We nix the 1,000. And instead, we're going to use a different divisor. Now, I've said that let's use the divisor 975. So take each of these populations and calculate, if you use the divisor 975, what the modified quotas would be. And then use Jefferson's method, give everybody the lower quota, and the number of representatives should work out with this divisor. So push pause and come back and do that. Alright, so you should have seen, or you should have gotten, that on these modified quotas we get 39.326, 21.774, 5.025, 20.928, and 15.511. So if we're using Jefferson's method, then the number of representatives for District A would be 39, 21 for District B, 5 for C, 20 for District D, and 15 for District E. Now add those things up, right? 39 plus 21 plus 5 plus 20 plus 15, and you will get, 100 representatives. Okay? So once we figured out what that right divisor was, then all of the work was done for us, and we just had to give the lower quota. So the hard thing is figuring out what this, what the divisor should be. And there's not a whole lot that can be said about this. Obviously, the divisor in Jefferson's method is going to be lower than the standard divisor. But how much lower? Well, you have to kind of do some trial and error kind of things. All right? So if we look at this example, that we had this example with Hamilton's method, you get 2635 plus 712. How many people, I'm calculating how many people are in this example. Well, there's a total population of 10,078. Population 10,078. We want 100 representatives. So my standard divisor, take 10,078 divided by 100, is going to be 100.78. So the divisor that I'm going to want is going to have to be less than 100.78. But how much less? Well, I don't know. Maybe you can go down to 99. Maybe you can go down to 95. Maybe you want to go down to 90. It really depends on a few factors. And there's no better way of saying this, but you just have to kind of use some trial and error. And it's not going to be a nice thing always. So maybe we try, for instance, having the divisor be 95. Well, let me write it up here. So you just try. Imagine that the divisor is 95. Okay? So take all those populations, divide them all by 95, see what we get, and see what we get for representatives. All right? Push pause on the video and then we'll come back and do that. All right, you should have done that. And, oops, I typed something wrong in my calculator there. So if I divide everything by 95, you'll get a modified quota on District A of 27.74, 7.49, rounding these to 2 just for quickness sake. And notice in Jefferson's method, you really don't need to compare the decimals like we did in Hamilton, so it really doesn't matter. 21.168, 40.758, 6.105, and 2.821. All right, and so your representatives would be 27. Oh, this pin's ugly. 7, 21, 40, 6, and 2. And if you add up 27 plus 7 plus 21 plus 40 plus 6 plus 2, all of a sudden you get 103 representatives, which is obviously too many. Okay? So, bad news, we got it wrong. Now, here's what I will say. On this thing, you do want to, kill all these numbers. But don't forget, if we use the standard divisor, our modified quotas would have been lower than what we wanted. Here we got higher. So with 95 as my divisor, we got 103 representatives. So I know I need to get somewhere between 100.78 and 95 to get the right divisor. So hopefully you caught that. In other words, what I'm going to do is I'm going to pick something that's bigger than 95 but less than 100.78. Okay, so maybe we pick another one. Maybe we pick, let's go right between those, 97.5. Okay, and modified quotas with 97.5. Push pause, calculate all of these, and then obviously you can calculate the representatives too. All right, so hopefully you did that. In this case, I get 27.026, 7.303. Pen's acting a little better. 20.626. 39.713, 5.949, and 2.749. So my representatives in this case would have been 27, 7, 20, 39, 5, and 2. Okay? And if you add those up, 27 plus 7 plus, 27 plus 7 plus 20 plus 39 plus 5 plus 2, all of a sudden that actually gives you the exact right answer. Exact answer that you want. All right? So we can stop there. This divisor of 97.5 will work. By the way, there may be other numbers that would also work. So for instance, my 97.8 might have worked. 97 may have worked. Maybe 96 worked. I'm not saying that those numbers do. I'm just saying that there are other numbers that would work. And it turns out that whatever number worked, it would be right around 97. And although these decimal points may be different in the modified quotas, they would all give you the same number of representatives. Okay, so if 98 worked, it would still give you 27, 7, 20, 39, 5, and 2 representatives for my districts. Okay, so everything hinges on getting this right divisor, and it's sort of a trial and error thing. You know, you may try the standard divisor, you may go down. You know, maybe you go too many reps, so you go back up. Maybe you get too few reps, so you go down again. But you have to keep trying and keep trying until you get the right divisor. All right, so we saw how that worked and how everything hinged on getting the right divisor. Okay, and then to get the right divisor, it's a trial and error kind of thing. So what I want you to do is take same example as far as the districts go. So the population of these districts is still altogether 10,078. Now if we want 120 representatives this time, right, we divide that by 120. So my standard divisor is about 83.983. Okay, so I want you to come up with a divisor that gets us to 120 representatives using Jeffersons method. And I want you to, on your own, sort of trial and error this until you get the right thing. Alright, so hopefully you push pause on this. Now, this one is a very difficult one to try to get the divisor for, and that's kind of partly the reason I picked it, because it's really, you kind of have to hone in on some things. Now, I came up with a divisor of 82.35 that would work, okay? And if I did my division I got 31.998, 8.646, 24.42, 47.019, 7.04, 3.254, which ended up as representatives being 31, 8, 24, 47, 7, and 3. So if you add up 31 plus 8 plus 24 plus 47 plus 7 plus 3, you get 120 representatives the way exactly what I wanted. Now, let me just say for where I did and how I did this. Basically, I had to pull in a divisor and get a number of representatives, and each time I did this, I was a little bit off. So I knew I wanted to go less than 82, so I started at 80. And I got 123 representatives. Again, that took a lot of calculation to get there, but that's what I got. Then I went up to 82, and I got 121. So I knew I still had to go up. Then I went up to 83, and I got 118. So I knew that the number of representatives, the divisor, should be somewhere between 82 and 83. Notice that in this case, a whole number won't work. You're going to have to get, a little bit in between. So, naturally, you guess 82.5, and you get 119. So you got to go a little bit lower than that. And I chose 82.2, and I got 121. And so halfway between there, well, first off, I did an 82.3, and I get, again, 121. And I did an 82.4. This is 2.4. And I got 119. And so I said, well, let's go halfway between 82.3 and 82.4. And I got 82.35. And that all of a sudden worked out to give me the 120 representatives I wanted. So, again, you might have to do a lot of trial and error to get this divisor. And it's not a nice, pretty thing every time. Okay, here, notice that even to the 10th decimal places, if we're skipping by decimal places of 1/10, 82.3 and 82.4, one of them gives you a number bigger than 120, and the other gives you a number that's smaller than 120. Now, I will say that, like on a test or something, I'm not going to give you one that's at quite that difficulty level. But you can see that in this case, we had a lot of things that were right around 0.998, 0.0s. These were all really close to the cutoff values. So that's why things were being thrown off and why we had to get such intricacy to get this. Now, let's take this 100 representatives sample. I want you guys to try to get a divisor, a modified quota, and the number of representatives using Jeffersons method with this example. All right, so push pause on the video, try to do it, and then come back. All right, this one should have been a little bit easier. And in general, when you have bigger populations, these divisors are going to be a little bit easier to come by, and a little bit more diverse things. So I guessed here we had 100,000 people. We wanted 100 representatives. So our divisor starts at 1,000. I did the modified divisor, which was 975. And then my quotas came out to be 50.2 243, 6.301, or 6.302 actually if you round it, 7.429, 21.892, and 16.698. So the number of representatives we'd have had would have been 50, 6, 7, 21, and 16 using Jefferson's method. Okay, and that's more like something that I'm going to give you on the test. It's going to be a whole number and a fairly nice jump, that going. By the way, don't always assume if the population is 100,000 and the representatives is 100 that you're going to have 975. There are cases where 975 doesn't work. Okay, and so you have to play around with that a bit. But in this case, we see that, excuse me, that we get 50, 6, 7, 21, and 16. Now, the reason I chose this example was because of, in this case, District A. I want you to notice something about District A. With the standard divisor, the quota of District A was 48.987. Now, if we were going to do either the lower quota with the standard divisor, we'd get a 48. The upper quota with the standard divisor, we'd get 49. So you would hope that in any method, A would either get 48 or 49. Hamilton's method guarantees that. Remember, Hamilton's method, you either get 48 or 49, depending on whether it's one of the things that we add one or don't add one to. Notice what Jefferson's method grants District A. It grants District A 50 representatives. That's higher than the upper quota. And that's the issue with Jefferson's method, okay? We have this thing where it is possible to get more representatives than the upper quota. And that's called a quota rule violation, okay? And by the way, there's two quota rule violations. One of them is you can get more than the upper quota, and the other one is you can get less than the lower quota. Okay, and Jefferson's method allows for quota rule violations. So we're not going to see the Alabama paradox or the new states paradox, but you will see quota rule violations using Jefferson's method. And in fact, Adams and Webster's method, it is also possible to have quota rule violations. Okay, so it is a little bit troubling using this different divisor. We could get something that doesn't, fall in the bounds of our standard quotas. All right.